Okay, welcome to the fifth lecture of Energy, Environment, and Economics, the Biophysical Approach. This is Charles Hall. And this lecture, we've covered sort of from an energy perspective, the origin of Earth, the origin of life, the origin of humans, and then cultural evolution up to the point of the Industrial Revolution. And now we're going to talk about the role of energy in a series of issues that are affecting society today. And they include peak oil, energy return on investment, and the concept of limits to growth. And these are things that I have been engaged in for my entire professional life. And I will give it both from my perspective of an overview and a little bit about my own personal engagement with this, which has been very interesting to me. And talk to you a bit about how science progresses, which is not necessarily in a uniform, straightforward manner. um, so let's look at the concept of non-renewable resources and the pattern of use over time. And from my perspective, back when I was studying as strictly as an ecologist, meaning focusing on nature, examining fish migration as a graduate student at the University of North Carolina back in the late 1960s. And here I am, and you can see I've got a screen over on the left where I've cut off the movement of the fish and forced them into an upstream cage and a downstream cage.
Charles,
Um,
I don't think we're seeing this. I'm not. I'm seeing
not
the opening slide for the whole program, Energy, Environment, and Economics, a biophysical approach.
really,
Yep.
I have no idea what to do.
Looks like you have slide one highlighted. And if you click on slide, whatever slide you want to show us, maybe four, click on four on your
Or
computer.
use the slider and go down to the slide you want.
But you have to click on it. Yeah.
No, he can use the slider next to
All
the
right, now,
power.
now which one do you
There you
see?
go. Now we see it.
Do you see only one slide or do you see all the slides on the left?
There's some slides on the left, but we do see the one you've selected, which is number four with you fishing
I
or something like that.
um all right, I'm going to try once more. Now, if I do that, you see me with the fish trap, right?
Yes,
Yes.
And what do you see now?
Same thing.
fishing.
You'd have to
Hey,
click on the slide that you want us to see because I see the highlighted box around number four. If you go to five and you click on it, it's going to
I
highlight.
understand. I'm going to have to
Okay.
go like this. All right,
Yeah.
so
Manual.
we'll do it manually. Then one fateful day, I was browsing in the bookstore at UNC and found this Resources in Man back in our less politically correct or actually correct this book on resources in man. It's back when the government used to undertake large studies and pay for it and get all kinds of experts together to discuss issues of great concern for the country. And there was at that time, if not a singular view, at least a sense that the it wasn't delivered from a political perspective. It was delivered from, let's see what the facts are. And I was very influenced by this book, which I just took home and, read bingo. I was so intrigued with it. Now, remember, this is when I'm thinking about fish mostly. In fact, I think they had a chapter in there about fisheries. But in this, I found a chapter by this guy, M. King Hubbard, and who later in my life I got to know fairly well. And he came up with this concept of what we call a Hubbard curve, later called peak oil. And it was about depletion. And as every beer drinker knows, the glass starts full and ends empty. The quicker you drink it, the sooner it is gone. That's a very important issue. The same principle applies to oil and gas. How has this self-evident principle, reality, been concealed? It is so obvious, yet it is a devastating realization. And these are the words of another fellow I got to know rather well, Colin Campbell. Not a very clear picture, but if you look at in front of him 3 glasses of Guinness, and I showed you this before, and this is his perception. This is about where we were with respect to oil in the ground in 1900, 2000, and 2100. The glass starts full and eventually it will be empty. And the important thing is the faster you drink it, the sooner it'll be gone. And this was really got me thinking. And I'm thinking, well, this is going to happen mostly during my lifetime if I live to be an old man, which I have. And so he also came up with this concept of Hubbard's principle. This is the epoch of fossil fuel. That means coal, oil, and gas in the sense of human history. Here's where Stonehenge was built. The Parthenon completed halfway up there. Pyramids constructed. Mayan culture. Here's where the steam engine was first produced in about 1750. And here is the exponentially increasing and then inevitably exponentially decreasing other side of the curve. And some people call it Hubbard's pimple. And certainly on the scale of how long we think human society, well, we know how long it has existed and how long it might continue, then this really hit me. The oil that everything is dependent upon, and I spent quite a bit of time. Think of the picture of the 33 horse-powered, horse animal powered harvester and the 200 horsepower petroleum powered harvester. What a difference oil has made in our life. It means we're not all out in the fields or doing what my father did, which was carry cow turds from the barn to the fields where they grew the food for the cows. So this was the idea of Hubbard's principle, and his first graph for the United States looked like this. He is doing this in 1965. And this was the jagged line up to that point was the use of oil to that point. It was growing exponentially initially, but obviously no longer did. And then he came up with something that was astonishing in 1955 to say. It's interesting. He said this initially in 55, but this apparently was drawn in 1965. And so he said, well, there's going to be another downside like that. And here is 2000. Here is where he predicted we would be here by this time. And he was wrong. Or was he? And I thought, well, my goodness, this is really something important. And he also made a prediction for the oil at what's called Q infinity. That is the total amount of oil that'll ever be produced at 2 different estimates of the total. And this is about what we think might be correct. for conventional oil. Now, conventional is an important word here, which I will get into. But he had predicted somewhere around the year 2000, and he said plus or minus, we're going to have a peak in oil. And another thing that was important to what he said, if you're growing exponentially, it doesn't matter very much how much, at least on generational scale, what the total is. If you're growing exponentially, you're going to get to the peak. You see, there's only about 15 years difference between the peak here and the peak here. I am assuming you can see my cursor. So, well, what happened? Now, the first thing that happened is that the growth rate in our use of oil has slowed enormously and even become flat. This is for conventional oil. And if we look at back then, they thought U.S. crude oil production was going to go down, while the blue line, the top of the blue line, is what our consumption would be if we continued on this rate. And then this was that red blip there was what they thought Alaska, the Prudhoe Bay field, might add in. And in fact, the Prudhoe Bay was very important and then has declined and is much smaller now than you see on this graph. So in fact, it does look like oil graphs deplete. Now let's look at how accurate we thought he was in 2007 or 2005. This is a graph I made, and he made his prediction, and we're going back to this slide here for the United States. Now we're looking at whether that, which estimated a peak sometime around the year 1970, 75, how accurate was that? Well, here is the actual, Hubbard's prediction is the yellow, and the green is the U.S. actual oil production for the lower 48. And incidentally, when he made this prediction, Alaska had not been discovered. He said, there might be oil up there, but this is for the lower 48. And boy, it sure seemed like he was damn accurate. And so at that time, and this, I was teaching all this, I said, it looks like, we're in a very difficult situation for an industrial country that used to be the world's largest producer of oil. It's really dropping fast. And Alaska, the red diamonds here, makes only a relatively small difference in what was going on. And at that time, there were something called ASPO, or the Association for the Study of Peak Oil. There were groups of scientists in the United States. We had a chapter, and in Europe, led by Colin Clark and Jean Larrey, who were very, very active, and the world was paying a great deal of attention in about 2005, because it seemed to be what was going on. But then something happened. And we have to say, we peak oilers were wrong. And it was because of this guy. And this guy might be considered, depending on your perspective, either the savior or the destructor of our entire country. Because this is George Mitchell from Texas, apparently a very nice, benign guy. And he was watching his daughter drink from a soda of some kind using one of these dense straws. And it just gave him an idea. Turn that straw upside down and use it to go after oil. And in other words, horizontal drilling. So Mitchell, he originally did it for gas, but he also did it for oil. Now, if we go back to this picture I've shown you before about an oil field, and this is Colin Campbell's concept of an oil field where you have a geological anticline at the right depth, so you get the right temperature and you get oil. Now, remember, the oil is not formed here. Oil is formed deeper and migrates up through the Earth's crust. 99% of the oil and gas goes off into the atmosphere, but some of it is trapped where you have a seal, a rock that's impermeable to the oil and collects as a gas and oil field. And Mitchell said, let's go after the source rocks. Now, the source rocks are deeper. This does not have a trap associated with it. This is just a source field down here. And the oil that's in the source field, in other words, the source field is what makes the oil and then it collects in these traps. So we're going deeper down below the trap here, and like this. And here over here on the left is where a trap is and where the reservoir rock is. Now, what Mitchell said is we're going to go down into the source rock where there's oil, although it's more diffuse than in the trap, and we're going to suck that oil out. And in order to do that, this is the vertical, and the pipe going to the side is called a lateral. What they do is they drill a pipe from, and these pipes, these horizontals now go sometimes 2 miles in length, really, really deep. And I have heard that they put in hundreds of 30-06 shells and ignite them in some way and shoot bullets into the source rock here. But however they do it, it's called fracking. And then they'll get, initially they would put 8 or so fire trucks with very, very powerful pumps in series to get terrific water pump pressure and push the water down into this field and fracture the rocks. And then the oil would drip. They'd put some negative pressure in the pipe and collect the oil. And this fracking bloody worked. And you went from getting an average of 20,000 barrels of oil out of an oil well to getting 3 or 4 or sometimes 700,000 barrels. Whatever you want to say about fracking, and it's certainly not environmentally benign. It got us about 10 times more oil per well than had been the case in the very meager wells that we were drilling in 2005. Now, the fields that you could frack were spread all over the United States. And we started with the Barnett field down here in Texas. That's where Mitchell developed his approach. But ones that are very important are well, Barnett originally. Oh, I guess they have Barnett over here. Yes, Barnett over here. Eagle Ford, Haynesville, in Pennsylvania, the Marcellus formation for gas especially, and up in the Williston Basin in Montana and North Dakota. And it turned North Dakota, for example, into one of our larger oil producing states from near zero to medium large. I was studying this in 2010. They'd already drilled this many fracking wells by 2010. In other words, just in 2 years. And the yellow ones were oil and gas, the red ones were gas only, the green ones were oil, and the size of the hole of the circle indicates how much oil per day they were producing. So these were called the sweet spots. You see, they have wells all over, but they concentrated their drilling in the sweet spots. Now this is Texas, not North Dakota, but it shows you the density of these wells. There's a well every half mile. And if you think of a 2-mile lateral going out from each of them, well, here's a diagram of what that was looking like way back in 2010. You can see the laterals are very close to each other. So this is where the oil in your gas pump quite likely came from, in this region of North Dakota and in Montana. And our oil production, which was going down, down, down from a peak actually of about 12,000 barrels per day, 12 million barrels a day in 1970 to about 5,000 in 2005 or so. And then thanks to George Mitchell, it's gone up, and I couldn't find I didn't have time to get the latest picture, but it's up to a record actually during Biden's presidency, even above this little bump. This great decline was COVID, and it's climbed up to about here again. So it's an actual peak in U.S. oil production has occurred about a year ago, and it's almost at that level today. I keep an eye on it, wondering what the new administration's impact will have on production of oil. And the answer to as of last week was none. It's been flat. Okay, but we're going to leave fracking behind. So fracking proved us wrong and proved certain economists right, at least for a while. But let's go back to our oil history and my minor medium role in this. In 1981, I was a young professor at Cornell University working on fish, and I had a student, Cutler Cleveland, who said, well, let's apply your energy ideas about fish. Let's apply it to looking for oil. And we published this paper that was in Science magazine. And as I'll show you a bit later, it was on the first page of the Wall Street Journal. And so I established myself in the field. And incidentally, this isn't science. It's more science and nature. They're the best places to publish. And this was a pretty good experience. And that established my name, I suppose, amongst certain oil producers so that I can knock on their door. And in 2001, but then the price of gasoline went down during the 1980s and nobody cared about oil at all. I mean, whether they care about oil or not depends on the price at the gas station. But 20 years later, this guy, Jean Leray, Frenchman, who had been head of exploration for the French big oil company Total, and Colin Campbell, the guy with the Guinness Stout, I went to visit him because they wrote a very important book, at least very important to those few who cared about oil, including me, in Scientific American, called The End of Cheap Oil. Now, it's not the end of oil, it's the end of cheap oil. And we stayed at his beautiful French farmhouse that had belonged to his parents in the outskirts, way in the boonies of France, but it was beautiful. And I understood for the first time that the only reliable data on how much oil was left in the world was in the top floor of this farmhouse in France. In other words, he had a computer there, and he was well connected with all the oil companies. Everybody knew and respected him and sent him their data. And he was able to put together a good record of how much oil was left. And the issue that they had, that he had at that time, was here is the rate at which we found oil, which is in the vertical bars. And here was in the rate that we're using it in the black heavy bars, that's production or extraction. And the rate at which we were finding oil was decreasing every year, and the rate at which we were using oil was increasing every year. And so, even though the price of oil had gone up considerably during this time period, the market had not found more oil. The amount of oil we were finding was declining regularly. And what I learned from John was the official data is very unreliable. They meaning those who maintain the data, asked political entities for reserve estimates, and they're given estimates that are based on often political perspectives. Revisions and additions, in other words, you find an oil field, and then over later years, you find that there are, you normally revise the amount of oil in the oil field upward because they sort of hide it for tax purposes, are treated as if it were new oil. And many of the large fields, which supply half the world's oil, suddenly crash. This is pretty amazing. So here's Cantarell. It was the second largest oil field in the world in Mexico. And they tried to get more and more oil out of it by injecting nitrogen. And they did for a while, but that caused it to crash very, very rapidly. Here's another big, excuse me, Jean and Hubbard originally came up with the concept of what's called Hubbard linearization to find out when an oil field or a gas field will stop producing oil. And they did it originally for Pennsylvania anthracite, and it's a mathematical treatment of the annual production over the cumulative production. And if you extrapolate that, it eventually goes to the total amount of oil, or in this case, coal, you produce from a particular field. And you see, you get an idea of the slope way back. So early in the depletion of a field, you can get an idea of the total. Even when you've produced only 20% of the resource, you can get a pretty good idea of what your total production will be. And John has used this, and the results indicate, yes, that fracking has saved us for a decade or two, but it's not going to indefinitely. And so that's something of great concern to me. Now, but wait, the official estimates are going up, 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 up. How can that be? Well, I wrote this paper, which I will send to anybody who asks me, from Jean Larare and myself and Roger Bentley, and we published this a year and a half ago. And fundamentally, we find that we are still using far more oil than we find. It's got to run out eventually. The official estimate of oil is the red line, but the actual amount of reserves is the green line. That's our graph. And the whole world is being misled. that we're still increasing our reserves when in fact we're decreasing it. Now, this is for technical reasons, and I'll explain if anybody cares that much, but it was based on using Hubbard linearizations for what's called all liquids for crude oil, which is just the good stuff you get out of the old traps. And then we add in, I got to remember how I did this. This is a correction for how much fracked oil there is likely to be. And this is a correction for how much heavy oil, like in Canada, there's going to be. The net result of all of these is that we have reached a peak, and it seems inevitable that we're going to go down. This is our prediction of crude oil. This is just the good old stuff from the oil traps. If you add in fracked oil, that's the difference between the purple and the blue. It's certainly important now, but it's not going to be very much in the future, is our best guess. You add in the heavy oil in Canada, the tar sands, and you add in what's called natural gas liquids. Natural gas liquids are when you take gas out of the ground and you release the pressure on them, liquids come out. So you can be either very uncomfortable because conventional oil is going to drop off, I think, inevitably very soon, or you can breathe a sigh of relief because natural gas is still expanding, and natural gas liquids, meaning propane, butane, pentane, heptane, are going to save our tail once again. That's the best I can do for a prediction of how much oil will be there for your children. And at the most optimistic, we predict by 2040 or 2050 that all of these will be declining. So, but this is for the world. So the next question is, where is this remaining oil? And this is still approximately correct. Saudi Arabia and the Middle East have most of it. Iran has a great deal of it. The United States is not so terribly important, but larger with fracked oil. And Russia is very important. So this has a lot to do with the future of politics, I think. United States maintains a powerful position in the world because of fracked oil, which fracked oil now produces about 80% of our oil and gas. Without that, we would be an insignificant producer instead of the world's largest producer of oil. And so here we are with different countries. This is not quite up to date. Mexico, Europe has had peak oil from the North Sea. Central and South America.
I met husband and wife. They're a team. They work as a team.
Yeah.
She's the seller.
Excuse me, is somebody talking to me, or is it
is involved in.
Of course.
could somebody turn their speaker off, please? Their mic off. Thank you. Here's Canada. Azerbaijan and Russia is pretty important. But you see, they're all peaking for 6 of 8 continents. Peaking is a real thing. It just hasn't quite happened for the United States yet because of fracking. Fracking has saved our tail, but it doesn't seem to work hardly anywhere else. And so if you look at conventional oil, now look at conventional oil, You see the United States conventional oil continues to go downward. Typically, most countries have a pretty close to a Hubbert curve. Venezuela, Yemen, we've done this for 45 different oil producing countries, and most of them show a Hubbert curve. So more and more, the production of oil is in just a few countries, or export of oil, including Russia, Iran, if we let them, Iraq, Saudi Arabia, and few in North Africa. Venezuela has a lot of very heavy oil. It's not clear for political and other reasons that's going to happen. And you might say, well, if oil production, now this is data for the United States, is declining, why don't we just drill more? And that's what our president says, drill, drill, drill. But when the oil production of conventional oil started to decline in 1970, we did drill more and more and more, but we didn't find more oil. So in a sense, the geology holds the high cards. Okay, now, next topic. This is me again going back to my doctoral work with migrating fish and coming up with the concept for fish of energy return on investment. Sometimes it's called EROI or sometimes EROEI. I don't prefer that. And it's the energy delivered to society or to a species over the energy put into that activity. And we started with this paper in 1981, examining that for the United States, the oil and gas that we're getting over time, this is just a conceptual model, was declining, and the energy break even for drilling and extraction was increasing. And this was actually written up on the first page of the Wall Street Journal, giving me my 5 minutes of fame, as Andy Warhol says. And it really represents the best first principle. Humans use high quality, low cost resources before low quality, high quality, low cost resources before low quality, high cost resources. And we do the best stuff first. And to give you an example from oil, this is the size of the oil fields that we discovered in the United States. We used to find 40, 80 million barrel fields, and then we are finding much smaller fields as time went on. And so increasingly, we had to find a large field. We had to go offshore, and obviously this is a lot more expensive to make a structure like this. A lot more energy, takes a lot more energy than just putting up a drilling rig on the coastal plain of Texas. So we started doing this EROI for oil. And here's an example, Norway. This is oil and gas and natural gas liquids. And here's the energy cost for Norway from 1991 to 2008. So the energy cost is going up and going back. The production has peaked. And so we get, for oil and gas, the energy return on investment for oil alone has gone from about 40 to 1 down to about 20 to 1. And we have further data that indicates it's continuing to go down, well, not quite as steep. And the same was true for England. So just a little note in my life, here's a British Parliament, and here I am looking a little smug. I don't hope I wasn't smug, giving a presentation in Parliament on the future of English oil. And they had some of the best English oil scientist there to cross-examine me. It was quite an experience, I can tell you. And well, here's another picture. And I was saying, well, this is what's going to happen with England. It's going to go down, 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 down. And as their major oil fields went to zero, well predicted by the Hubbard linearization, incidentally. Let's see, that was Brent, and this, you hear the financial news talk about Brent crude. That's the best oil from Europe, the standard oil for England. So they have used Brent oil as an index of how much oil costs. This West Texas Intermediate and Brent crude. Well, there's no more oil produced from the Brent field. It's dead, as is the Forties now, as is several more. So this is their big fields. I think this might be Brent here, and no, Brent in the Forties down here. And you see they taper off, and then they find smaller and smaller oil fields. And so now the total production for England is only about, I think, 10% of its peak. And I don't think England is going to be able to regain its financial position because they don't have the energy to do it. So I did EROI of England, presented this to Parliament, went through all the details here, and it's continued to decline. So it's only about a quarter of what it used to be, and we've done this for all kinds of different countries. This is for the U.S., the dots, which are declining. And this is for a global estimate. And the purple is for, I don't know what the purple is for. I think the purple was Mexico. It's interesting, I don't. Now, one could say, well, you don't have to worry because something will come along. So these guys, Steve Moore and others in 2015 said, well, let's take our best estimate, and this is for all of fossil fuels. And we estimate that there will be a peak around, and that's around now. Or we can make a low estimate, and that peak is a little bit before now. Or you can say we can take our best guess estimate, in which case you get a peak in around 2060, 2070. This is the maximum estimates they found anywhere of how much coal, oil, and gas there was of the world. All kinds, fracked, heavy oil, everything. So sooner or later, we're going to have to deal with this peak and decline in fossil fuels. Some people say that's good for the atmosphere. Other people say this, if the high estimate is correct, there'll be so much carbon that it'll ruin our atmosphere. Well, take your pick. At the moment, something around the low looks most likely, but we don't know for sure. That'll be for the next generation to decide. They'll have the data. Meanwhile, the grade of all of our major metals is declining, meaning that it takes more energy to make a kilogram of copper or nickel or whatever. And there's the environmental effects of all this, which I haven't taken into account. And I just want to say that's important. So, in the future, energy return on investment will strongly influence net economic growth, cost of government, i.e. school bus fuel has already been important, ability to pay back international debts. We probably don't have enough energy to do that. and the ability of conventional economic models to work? And the answer to that, as we will see in the next two lectures, is they don't. Okay, the final thing I want to talk about is this concept of limits to growth. I want to talk about this as a historical entity. This came out in 1972 based on the 1969 paper that I read, The Counterintuitive Behavior of Social Systems by Jay Forrester at MIT. And my father had gone to MIT and got the MIT alumni magazine that had this paper in it by Jay Forrester, who was already very famous for inventing computer memory, random access memory. And then he tried to take his new tool in 1970, late 60s, and he made a beautiful book called Urban Dynamics. And if you're interested in cities, it's a great read. And then he did World Dynamics. And then his students, Donella Meadows, Dennis Meadows, Jorgen Randers, and also William Behrens, I don't have a picture of him, wrote this book, The Limits to Growth. And that has sold millions and millions and millions of copies, and where it's very influential. And they made computer models that had just about 7 parameters. Resources, they didn't say which resources, and food per capita, the human population, notice that peaks and declines, industrial output per capita, and pollution. And it showed the human population declining greatly, not by their choice, over their computer runs, almost no matter what they did. Pollution increasing, resources declining, eventually impacting food per capita and so forth. And I was, of course, very interested in this. The only way they could cause the human population to stabilize, see the straight line across here from population, was to do two things. They had to deliberately stabilize the population with birth control or whatever, but also to make the model stabilize, they had to reduce investment. Well, you can imagine this was not looked at very happily by economists. They hated it and had devastating critiques and so forth. And they said they did not like its biophysical basis, its failure to include human innovations, which they thought could avoid these material limits. And when the predicted dramatic changes did not come to pass, they loudly proclaimed the model to be a failure. But a problem with this original assessment, if we go up here and look at the original, you see they have 1900 and 2100 here. Everybody thought that didn't look very carefully at the timing. They thought the impacts were going to happen right away. And in fact, they were not. I did this with a ruler, I don't know, back in about the year 2000. And these things are not even supposed to happen by, well, maybe by now, food per capita, which was beginning to decline. But the population was supposed to still be growing. All of these things are true. And so when various people, including myself, looked at the predictions of the economy, the predictions of the model done in 1970, they were pretty good so far. And that's almost up till today. So is this model correct? Is the limits to growth model correct? Well, we don't know yet. But in many ways, it's right on the money. So, well, what about technology? There's a race between technology and depletion. And in the case of oil technology, which I'm particularly interested, new technology did not find new more oil, with one exception, which is fracking. So here is some earlier technologies that were tried for oil and they did not work, but fracking did. But we're still left with basically the economist's argument: technology will overcome depletion. And the geologist's argument is that depletion is real and will overwhelm technology. Who is right? And for oil, it seems to be depletion. In 1970, we got about 25 for 1 EROI. 25 units of energy returned from oil and gas for 1 invested in looking for it. In 1990s, we got about 11 to 20 to 1. I'm sorry, it should be 4-1. 11 to 20 for 1. And then, but that was mostly for just pulling the oil out of the ground. But fracking changed the ground, changed it all. Or did it? If you look, Adam Brandt, a friend that's at Stanford, has assessed EROI for fracking and found early fracking got 30 to 40 to 1, but it dropped very rapidly. So the question is, what's fracking going to be for the remaining fields? And nobody's done the studies of that. We don't know. Meanwhile, some of us think depletion is a much bigger problem than climate change. What should we be most worried about, be most concerned about? I think depletion, but I might be wrong. I was wrong before. Fracking made me wrong. Here's my final professional goal, which we will talk about in later ones. And I just want to show you my perception of what EROI means over time. Energy return on investment. Remember, that's my claim for fame, minor claim for fame. I suppose it might be more important eventually. Here's a simple model we made with Bobby Powers and somebody else. I can't remember it off the top of my head. And here's the economy, Billy. And so here's the economy that must exist within the world. And we call this the cheese slicer model. So the economy is generating cheese here. Think of Velveeta kind of moving out from left to right. That's GDP coming out. And you do two things, essentially, with GDP. You invest it or you consume it. Now, the investments have to go into maintaining your infrastructure, fixing your roads and buildings and whatever. You have to invest into getting energy. So the ratio between this line and this line is the energy return on investment. And then you have discretionary investments. That's build a new hotel or whatever you want to do, new house. And then there's consumption. Consumption goes into staples, food, shelter, and clothing that you have to have. And then you have discretionary. And this, of course, what everybody likes is discretionary. Going out to eat, going to a movie, whatever. Buying something new. So this was for 1949. And you can see it's a pretty nice balance between consumption and investments and lots of discretionary available. 1970, things had not changed very much. Now, in 1971, what happened was the oil crisis. I don't know if you remember that, but the gas lines and all of that. Well, the price of oil and other energy went way up. So that you look at 1981, this had become considerably larger, and that reduced the amount of discretionary, but not a lot, but we did become poorer during the 70s. And most of it was due to having to increase the amount of discretionary, the amount of investments that went into getting our energy. And then in 1990, it became small again. 2007, it hadn't changed a lot, but our projections were that EROI had to decline, our investments into energy would become larger, and the amount of discretionary that was left would have to become of necessity smaller. Remember, these are all in percent, not in absolute values, but in percent. And by 2050, ERI would cause very, very large impacts. An increase of ERI to getting back only 2 to 4 units of energy for every one invested would make a huge impact. And that leaves us with my final slide, that ultimately nature has a great deal of control over what civilization does, and nature is indifferent to us. And there we are. Okay, that's the end of my 5th lecture, and I will open this to whatever questions we might have.
You said one earlier, one of the middle slides, that generally we were getting only 20% return on investment in energy overall, or something. Did you say something about that?
Well, EROI had declined to below 10 for 1 for oil and gas by 2005. Now, remember, you don't want to simply that was a mistake in all of the people assessments, including, well, maybe my own. In the early days of EROI, was thinking as long as it was positive, it was okay. So for making alcohol, ethanol that you are forced to buy in your gasoline, it says 10% gasoline, ethanol on the gas pump. That ethanol is produced at about 1 unit of ethanol in energy for every 1 unit of oil and gas that are used to make it. So you can't run a country on that. You have to have somewhere probably around 10 to 1 to have anything like the kind of society we live in, where most people aren't producing food or energy, where people have the enormous affluence and leisure that, well, let's just say the upper half of Americans certainly have. That's how, I mean, that's just the way it is. And, but now, so I think you need around 10 to 1 minimum to have an affluent society. Does that answer your question?
Yeah, thank you. The other thing is you were saying fracking doesn't seem to be possible at other oil fields in the world. Is that what you said at some point?
Yes,
It's not
I
working.
did say that, and I'm very confused by that because we do it in so many different places in the United States. But
Uh-huh.
this is what the United States has. It has tremendous investment capital. So we fracked for a while when people were not making a profit. I wrote an article on it. I don't know if we did it. The
So
second
it can
thing,
be done. It could be done in other fields. It's just that they don't have the investment for it. Is that
no,
what you're?
they don't have the rocks either.
Oh, it's a
Yeah.
different geological situation.
That's right. The middle of the United States, for a long time was a vast inland sea, and it was flat. And so you laid down very large areas of flat rock for hundreds of millions of years. And there were mountains where the Appalachians are now, and there weren't before the Rockies were formed. It was all strata that was good for building frackable rocks. Now they have done it in Argentina, but they have not been able to replace their traditional oil. I mean, that's the thing that's happened in the United States. We've replaced, and more than replaced, our traditional oil with fracked oil. With this enormous number of, hundreds of thousands of oil wells. It's just spreading horizon to horizon in many areas. Now, China is trying, but China has a lot of very eager technologists and workers, and they can't do it. It just hasn't worked in Chinese rocks so far. Argentina is the only success story, and it's a sort of success. And the question is, when people get desperate, what are they going to develop? I don't know. But so far, and it's been 20 years that the technology's been available, nearly 20 years. And I think by now, if it worked, we would have a lot more of it. Estonia, for example, has a heavy oil, is developing another alternative source of oil, but it's just been too expensive. So they've almost stopped doing it. And Venezuela has a lot of potential, but it's political chaos. Here's what happened in Venezuela. And I edited a book on it. I have it on my shelf here. So in Venezuela, they had a right-wing government that was in close cohesion with the oil companies in America, Schlumberger and so forth, who do maintain the oil fields. And then a leftist government came in and took the money that had been going to the oil companies, and I'm sympathetic, spent it, gave it to the poor people. But they didn't maintain their oil fields, and their oil production plummeted. So, I mean, it's even though I find myself in general sympathetic to distributing wealth to the poorer people, if your wealth is dependent upon oil, as was the case in Venezuela, you got to maintain your oil wells. You've got to do that, what the conservatives were saying, you got to maintain your relations with the oil companies to maintain the oil fields, and they didn't do that, and there was depletion. So there's a lot of oil left in Venezuela, but not much is coming out of the ground. And Ecuador is facing the same issue now. So I have a lot of particulars on those two places, should you be interested. I'm not expecting, but
Thank you. That was really informative. Thank you. Okay.
Okay, good. Yes, Mark.
Yes. First, I want to say that this is the most new information I've received in any of the sessions so far, and I want to thank you for that. This
Good.
EORI concept around petroleum and fossil fuels and stuff, I've had just a perception of it, but I really appreciate the graphs and the data that show how it plays out. So I'm wondering, I'd like to suggest that you get an audience with President Trump and show him these graphs so he can understand that drill, baby, drill is not the most cost-effective policy for spending our tax dollars, and that we need to simultaneously, like I just illustrated with Venezuela and Ecuador, that we need to simultaneously be funding research and development of renewable energy resources too. And I get that he misses that because of his commercialism and wanting to support his billionaire oil investors. But that's, to me, a very short-sighted path based on the information you saw us here about EORI.
Thank you very much, and I absolutely agree with you, except for one thing. I cannot imagine that President Trump would ever want an audience with me.
Somebody's got to tell this to him. It doesn't seem to be hearing it.
Um, yeah. Well, he's shutting down our science. He's trying to destroy our great universities.
Yeah.
You know, I'm sorry. I think you'll see it this Thursday on PBS. I'm carrying a sign up a couple of weeks ago up in Medford. Sorry, we're not supposed to be political, but you'll see it Thursday night on television if you watch PBS, I think. And it says, "Make America Great Again. Destroy science, destroy our universities, destroy our healthcare."
Yeah.
You know, a whole list of the things. Now, I apologize to anybody I'm offending, and I want to get away from politics, but yeah, I mean, I think if you have I mean, it's a fact. We have an administration that's attempting to destroy our great universities and well, all universities perhaps, and bringing in what the strength of our universities. So much of it is that we get these bright kids from other countries that come in here and just really flourish. I've had many of them as graduate students, and they've gone on to do great things in their countries and in ours too. And so it's crazy to me. But anyway, yes. How do I get the message out? I have asked this question for 40 years because I've understood basically, I have no children because I understood this back in 1960s. And so it's not that it's new, and it's not that I wasn't on the front page of the Wall Street Journal with this information or published 12 papers in Science and Nature on these issues. It's there for anybody who wants to see it. Now, one of the problems, though, is people pay attention to me, to us, to Jean Lerer and whoever, pay attention to us when the price of gasoline is high. But the price of gasoline is not high. And at the moment, might be going up a little bit, but not much. And so people say you're wrong. And I was wrong. I was wrong about fracking. We were all wrong about fracking. George Mitchell changed the game for all of us. And lost whatever credibility we might have had with the general public. So there you have it.
Thank you.
But Charles,
go.
fracking is really just sucking the dregs out, right? It's not
No, it's good. It's
Yeah.
good oil. It's light oil, meaning low sulfur and low molecular weight. It's source oil. It's going after the oil where it's formed, not where it happened to collect. So the thing is, it's diffuse down there. And George Mitchell had to develop all this stuff shooting off 30-06 shells into the rocks and pumping with fire.
Sounds barbaric.
It's just incredible. But he did it.
Mhm.
And went from getting 20,000 barrels to getting 300,000 or 400,000 barrels out of a well, even
Wow.
though it was a more expensive well.
That's incredible.
So yeah, technology, I have to say technology can sometimes make a difference. And is there another technology? I'll tell you another technology there might be. It's getting them out with bacteria. And I'm involved in this too, is that it's not, people have known for a long time that bacteria can chew oil, oil is like an oil-soaked brick in the ground mostly. And the trouble is the oil droplets don't go through the sand grains or whatever it's in. But if you can make the droplets smaller, you can do it. And we can do that with bacteria. And but you got to use the right technology to do that. And anybody wants to know where to make a good investment, look at Apex Petroleum. Then this might be, but that will only be extending the life of oil wells. You can make a new barrel of oil for $5 worth of nutrients if you know the right ones to use. And it all goes back to ecology, to a guy named Liebig, and Liebig, which I talked about briefly, Liebig's law of the minimum and so forth, and that's been put into action with oil field bacteria. It's quite interesting. I don't think it's going to make a lot of difference. It'll make a little difference. Fracking make a lot of difference only for the US, which is quite astonishing. Yes, Meg. Turn on your microphone, please.
Right. So in the next, are you going to be talking about, I mean, this is interesting about the bacteria, but about other ways of harvesting energy, for instance, geothermal and wind and solar. Are you going to be talking about that in the next couple of lectures? The viability of those and recommendations?
No, but do you watch PBS?
Sometimes.
Do you know what Passport is?
Mm-hmm.
Go on to Passport
Mm-hmm.
and look for Energy Horizons. It's a 6-part series on all of the different types of possible energy, focusing on Oregon. And the first and the 6th presentation has a lot of yours truly. And it's not part of this class, but you'll get it's a beautiful series. Keegan Van Hook has done a really great job on doing that, and Trip White for filming it. And it's very oriented towards Oregon. And they interview a lot of different people that are gung-ho, the different renewable energies. And then they interview me, who let's just say has a sort of broader perspective. Keegan said to me, thank God we had you as well as everybody else. But I think it's a superb presentation. If you can't find it, I can send you the link, or if you want the link, just email me and ask for it, and bingo, and there you'll go. And you'll see my dog too is on TV.
If we do that, do we have to have Passport in order to access it still?
I think maybe you have to contribute to PBS to get Passport. So will you email me, Meg?
Mhm.
Well, you know what I did this week? I used last year's list of people to email out. And so I tell you what, I'll email everybody the link, and hopefully using the right group of people, okay?
Thank you.
Weird, yeah.
So Charles, isn't renewable
Who's
energy,
speaking, please, will you? Who's speaking?
Diana?
Diana, okay. Do you mind you don't have to turn on your
Okay,
thing, but I
here I
like
am.
to feel like I'm talking with a person.
I know, I'm sorry. I'm just up and down sometimes during the lecture.
Yeah, yeah.
Um, I, you know, alternative energy, I think they're finding this out for wind, and it seems like there's a lot of issues with solar, but the footprint, the energy you have to use to develop these sites is astronomical. I mean, these things are shipped from Brazil. Copper has to be taken out of the ground. And you just mentioned that even metals are becoming harder and requiring more energy to mine. And it's just hard to
And
see.
an electric car has 3 times the copper of a internal combustion car.
Have you
Not to
run any
mention the
numbers?
charging stations and stuff.
Right, right. There's so many things. I mean, that list is very, very long. And putting in, these infrastructure projects, I think they're about done with wind, if I'm not mistaken, because it's just really not feasible. But have you ever run any numbers about like the ROI on that?
You bet.
Oh yeah. Well, you're not talking.
I'm involved with it. I'm involved in critiquing the assessments and doing my own assessments daily, every day.
Mhm.
So the answer is sort of. Um, the wind turbines, the best assessments are done by, I'm trying to remember her name is, uh, but I could send them to you. Her name is DuPont, Elise DuPont. If any of you want the scientific guts of anything I talk about, I've got them. None of this that I'm saying, except where I warn you, is based on nothing. They're all based on reviewed scientific papers, and the only thing that can protect truth and reality is something called peer review. I'm a great believer in peer review, and that's another thing they're trying to implement from the top in the US political scene. Peer review, they're trying to replace that with political review, which is crazy, just crazy. So, so wind turbines are 18 to 20 to 1, and they're probably getting better because they're building them higher. Why does that matter? To build them higher because there's more wind up there. And it's the more important thing is it's more regular, so you don't need as much batteries for backup. And so I've been in very fierce interactions with people, including one of my own former students who I really admire most of his work, but I had a real difference of opinion. There are people who say that EROI of renewables is now higher than fossil fuels, and I don't believe that's true. But the EROI of fossil fuels is going down with depletion, except for fracking, and the EROI of renewables is going up as we become better at it. And where are we now? I can't tell you exactly, but I would say the best fossil fuels are clearly better than most renewables, but it's going in the direction of renewables, and it's just crazy to shut down our renewables program. The thing that's missed in this whole thing on on shutting down the renewables is, on the Energy Horizons, on the program that's on PBS. The things that's missing from it is they're only talking about electricity, and for the country, electricity is only 20% of our energy use. And so they're talking about, all this great stuff about making electricity, but 3/4 of what the energy we use is fossil energy still. And so what about the other 3/4? What about the trucks going up Route 5? What about all the energy that's used everywhere you look in construction? It's run on diesel, and delivery of all our food is diesel. And anything you want to change is done on diesel. And protecting the coast from the sea level rise is done with diesel, and on and on and on. Catching their fish is done with diesel. Replacing diesel is going to be a lot harder. Replacing gasoline, maybe.
What about nuclear? Where does that fit in? I mean,
Ne-
you know, it
next
seems
question.
promising.
Okay, I have worked at 2 nuclear labs, Brookhaven and Oak Ridge. And I guess I've said this on this program, but if you watch the wonderful movie, oh God, Oppenheimer, it's a great movie, and I knew some of those people, a couple of those people in that movie. I was up to my elbows in nuclear for a long time. And my policy, people keep asking me for policy. I don't do policy. But if you press me, I like nuclear. I'm not worried about waste disposal. I think we can do it if we set our mind to it. We need to have a lot of government control in doing that and all the goods and bads that are related to that. And you got to remember, we're not talking about building 400 nuclear power plants, which is how many are in the world today. We're talking about building 40,000. This is what scares me. That means that we got to generate 10 million nuclear technicians at various levels to be able to do this, which means that, and I figure 1% of 1% of 1% of them want to kill you and me or somebody. And if they have enough technology to make a dirty nuclear, to make an explosive nuclear bomb is really difficult. But it's not hard to make a dirty nuclear bomb, which means you just take some plutonium and fill a barge full of ammonium nitrate fertilizer and put a cup full of plutonium on top of that and sail it into New York Harbor and ignite it. That kind of thing scares me. So I say, well, let's see how far we can push renewables. So when push comes to shove, I'm an advocate of renewable as much as we can. I'm also an advocate of degrowth. We don't need much of what we have. We need to share what we have much more widely. And we have to work on allowing the women of the world to have as many children as they want, not as many as they are forced upon them. And that's all you need to do, in my opinion. But, distribute and increase the rights of women around the world. And that's at least a good part of the way. But whether you can do that in today's political environment, well, that's just about as likely as Donald Trump inviting me to his office. Peggy.
This has been so interesting. Thank you. I really would love it if you could send us some of these links, because I'd like to look into them further, and I'd like to share them with other people because I think it's important information.
Well, don't forget, we've got this lecture on.
I know.
It takes Eric a little bit to get it up, and
Yeah.
everybody send a thank you to Eric if you want.
And what is the PBS Passport show again that you mentioned?
Energy Horizons.
Energy Horizons. Okay, thank you.
Geez, it's been on Thursday nights, 3 cycles.
Okay, I'll look. Thank you.
But you just watch it and make sure you see number 1 and number 6, because that's when you see me.
Thank you. Okay, good. Thank you.
If you want to.
I do.
If you want to.
Thank you.
Well, this is good. I don't know. I think we're down to fewer people, but they seem to be really enthusiastic.